Hello, class. Today I'd like to talk a little bit about the different types of fits of components that you might find in the automotive trade. And this is true for a lot of machine work, but we'll talk from an automotive standpoint. So you see on the slide, we talk about three different fits. I'm going to start from the right-hand side. There's a clearance fit. In the center, they talk about a transition fit and then an interference fit. So a clearance fit means that there's actually clearance between the two items. So in this slide, we see that the shaft, if you look at the measurement of the shaft itself, it's 49.9, let's say, millimeters. If you have a gear or something that goes over it, that the hole in that measured 50 millimeters, then we know that there's some space between the two. So we've got a shaft, or a shaft in here, possibly, right? If that measured 49.9 millimeters, the hole in our gear measured a steady 50 millimeters, then there's room between the two that they fit together and go together very easily. There's actually some clearance in between the two so that we allow oil to go in there and lubricate it. So they slide together very easily. The next fit that we talk about is a transition fit. That's a little bit tighter fit. So again, if we think about the shaft as being 49.9 millimeters, and here I've got a gear on here that if we measured the hole on that as 49.95 millimeters, well, there's very little difference between the size of the shaft and the size of the gear. That means it fits much tighter. And although I can put it on by hand, if I'm very careful about it, and I get it very straight, this one I'm actually wiggling on a little bit, you can see that it goes on and off quite tight. Now it would require something to hold it on there. In this case, there's probably a snap ring or a nut that goes on the threaded area that holds that in place. But that gives a much tighter fit between the two because one is driving the other. Now the one that's a little maybe odd to you is the next one, in which we call a interference fit. And if we look at that, and if we were to measure the shaft there at 50.080 millimeters, and the hole in the center of the component that's on it at 50 millimeters, well, there's something you might realize by that is the shaft is actually larger than the component that's going on. How's that possible, you ask? Well, that's what we call an interference fit. It's two things trying to occupy the same spacing. So because the shaft is larger than the component that's going on it, in this case, the inner race of a bearing, it takes some special work in order to get that together. Now, I'll tell you the reasoning behind that is the fact that this is a ball bearing. We've all seen ball bearings. Well, this is a ball bearing as it's installed. This is what we call an outer race. This piece is an inner race, so it's grooved so that both of these races are grooved so the ball bearings ride in them. In order for a ball bearing to work properly, the balls have to be able to run inside these races independent of one another. So what we do is we'll have an interference fit on one section and likely hold the outer race on this particular one so that it's stationary in a housing of some sort, and that way the balls are free to rotate independently of both the inner and outer race. That's what makes them work properly. So back to the fit itself, how do we make that work with an interference fit if the shaft is actually larger than the inner race of the bearing? Well, there's a couple of ways in which we can do this. It means that it's not going to be able to be assembled by hand just the way it is now, that we're going to have to do something with it. So the ways we can do it is we can use a shop press, so a hydraulic press, and we'll be looking at those in a bit, and we'll actually use force to slowly force one component over the other. So I'll have a press and I'll put it on the inner race, I'll support the shaft, and I'll be able to force it down with a hydraulic pressure. When we have an interference fit like that, the other thing we know is that I'm not going to be able to pull it off by hand. So I actually need a puller in order to pull it off, a puller of some sort. And that's where we're getting to in the next couple of slides. Uh, but just to say there is another way we can do this. And this is often used, this is likely a gear out of a transmission. So it's often used in transmission work, is we can actually heat the component independent of one another. And when metal heats, it expands. So if I were to take this bearing when it wasn't installed and I actually heated it up a certain amount, and it doesn't take a lot, it's usually a couple of 100 degrees. We don't want to heat it enough to damage the metal or to change the metal. So if I can heat it up a couple of degrees, and some places, some manufacturers will even suggest that you cool the inner part. So I could take this gear if the bearing wasn't on it. So before I put the bearing on, if I had this gear and I even place it in a freezer to get it very cold, I take the bearing that I'm going to install on it and I put it in some heat, heat it up to a couple of 100 degrees, probably with a heat gun. I can do it with a torch if I'm really careful. I've even used for more controlled heating, I've even used a toaster oven in the shop so that I can heat that just to a couple of 100 degrees. Then when I could grab it, I can actually put it on there. I'd have to have something to install it with. But with the colder gear and the warmer bearing, I can have to actually set the bearing in place because it's actually changed the size of the hole inside that bearing. So that interference fit takes a little, a little finesse and a little special work in order to get it on and off, and you need to be careful. The big thing you don't want to do is use any amount of force. If I try to hammer this apart with a hammer, I'm going to do damage to something. Now, some bearings that don't fit real tight, I might be able to install them with a hammer and the right size driver, but typically pressing or using a puller or installer is preferred, um, you know, because there's less chance of doing any damage to the component. So that's an interference fit. If you want to Google some interference fits and the way they're installed, the way pullers are used, the way shop presses are used, like I said, we're gonna explore that a little bit in the next few slides. But kind of neat to watch that actually in action, that you can see these components put together, although the outside component is actually smaller than the inside component. So I hope that helps, and we'll move on back to the slideshow and we'll look at some pullers.